Hello children, so let's go to the next set of reactions. We had discussed decarboxylation and now we move on to the reaction with phosphorus halides and thionyl chloride. Okay, so we have phosphorus pentachloride, phosphorus trichloride, and we have our thionyl chloride, which is SOCl2. Okay, so we'll discuss how our carboxylic acids react with these three reagents. So let's start with our PCl5. So in general, with PCl5 we generally get the acid chloride. Okay, so here what is happening is that the C double bond OH, the OH is replaced by the corresponding X, okay, halide, and thus we get a set of compounds which are RCOCl, which are called acid chloride. Okay, so let's see how the reaction with PCl5 will be. I will get RCH2COCl plus POCl3 plus HCl. So here this is my acid chloride. And now if you take, so for example, if I had taken benzoic acid, okay, and I had treated it with PCl5, I would get the benzoyl chloride. Now next let's take the reaction with PCl3. So when it reacts with PCl3, I get again the acid chloride COCl, and here we have H3PO3 formed, okay, which is your phosphoric acid. So here it's the same case here, and if I treat this with thionyl chloride, again I will get RCH2COCl, the same acid chloride, but here you will see the evolution of sulfur dioxide gas. So that's the reaction with your phosphorus halides and thionyl chloride. Next, let me take the reaction with ammonia. Here again, if I take the general formula of RCOOH, when it reacts with ammonia, okay, you will get a ammonium salt. So the ആദ്യം നമുക്ക് കിട്ടുന്നതാണ് ammonium salt, which is RC double bond O ONH4, because this is how the ammonium salt is formed. This decomposes to form the amide RC double bond O NH2. So this is how my alkanamide ഉണ്ടാവും. Okay, an example if I can quote is, let me take the case of acetic acid, which will react with ammonia to give ammonium acetate, which will decompose on heating. This has to be on heating, okay, to give acetamide. And water. Okay, similarly if you take the corresponding benzene, benzoic acid, I will get benzamide. Another reaction we have to discuss is esterification. So this is a very important reaction because it involves the synthesis of our esters. So here R C double bond O OH will react with an alcohol. Okay, I want to show that the OH is the alkyl group is different, and acid in the OH alcohol in the H ആണ് combine ചെയ്തിട്ട് you will have is a reversible reaction happening in presence of a mineral acid, and I will get R C double bond O R dash, which is what we know as ester. Okay, now it has been shown that it is the OH of the acid that goes to form the water molecule, because ഇത് നമ്മൾ ഒന്ന് isotope, if I take the O18, okay, ഏതെങ്കിലും ഒരെണ്ണത്തിൽ നമ്മൾ ഇട്ടാൽ നമുക്ക് എസ്പെഷ്യലി ആസിഡിൻ്റെ ഇതിൽ if you replace this OH with O18, the O18 isotope, നമുക്കത് കാണും that it will be seen, the radioactive one will be seen in the water molecule, which shows that it is the OH which is being combining with the H of the alcohol. Okay, so typical reactions we can talk about is namku methyl esters undakam, that is how you can another way of preparation. Okay, we talk about another preparation of esters can be also from when you react acids with diazomethane. Okay, this is diazomethane, and here I will get again RCOO CH3, because this part, that is methyl alkanovate, whatever is the alkyl group that you have taken, alkanovate. Here it evolves, nitrogen is evolved. If you take the example of acetic acid, I would have got methyl ethanoate. Now another method, okay, acids can be converted to esters via acid chloride. Acid chloride vadi namukku cheyam, that is like we already saw, right? Namukku thionyl chloride vechittu treat cheyumbo ee acid thionyl chloride വെച്ച് ട്രീറ്റ് ചെയ്യുമ്പോൾ നമുക്ക് HCl SO2 നമ്മൾ മൈനസ് that's what that are the other products. You will get the corresponding RC double bond O Cl. This is my acid chloride. This will react with another ROH, which are alcohol, and it will give me RC double bond O R dash. So inganem inike esters undakam through the acid chloride route. Okay, sorry about my okay. Then next let's discuss about halogenation reaction. Okay, the halogenation reaction is basically the reaction with halogen. Okay, and ഇവിടെയാണ് നമ്മുടെ HVZ reaction നമ്മൾ പറയുന്നത് Helmholtz-Zielinski reaction, HVZ. Okay, very important reaction. ഇതുപോലെ ചോദിക്കും, ഇതിൻ്റെ mechanism is very important, which we will discuss soon. Okay, so let me first discuss what the reaction is all about. Okay, reaction is അതായത് നമ്മുടെ aliphatic acids, aliphatic acids, okay, acids react with your chlorine or bromine, okay, in presence of a catalyst, which is generally phosphorus or iodine, etc. And what happens is that in this process it will undergo alpha halogenation. Okay, alpha position halogen add ചെയ്യും എവിടെയാണ് alkyl part. It will undergo alpha halogenation in the alkyl part. This is your HVZ reaction. So let's look at a typical reaction. For example, if I had taken acetic acid, അത് ക്ലോറിൻ വെച്ച് ട്രീറ്റ് ചെയ്ത് in presence of phosphorus, I will get, okay, I'll show you how that thing comes. It is carbon, see, CH3, C double bond O, OH plus, okay, OH LA. Here alpha position. So first, avade I will have my chlorine will get added, okay, and I will get HCl. Now this again, okay, this can again react with chlorine in presence of phosphorus to give again another substitution there. So I get the dichloroacetic acid, okay, again HCl. This again can react with chlorine in presence of phosphorus to give me the trichloroacetic acid and HCl. Okay. Now, ഇവിടെ എന്താ ഇതിൻ്റെ ഏറ്റവും ഇമ്പോർട്ടൻ്റ് എന്താ വെച്ചാൽ ഒരു എക്സ്ക്ലൂസീവ്ലി ഒരു ആൽഫ പൊസിഷനിൽ ഹാലോജനേഷൻ നടക്കുന്നതാണ് ഇതിൻ്റെ ഏറ്റവും വലിയ ഈ HVZ റിയാക്ഷൻ്റെ പ്രത്യേകത. ആൻഡ് നൗ let me take a higher aliphatic acid like propionic acid, okay. So in this case propionic acid CH3CH2 COOH ആണ്, okay. അവിടെ here let's take bromine, let's try to do bromination in presence of phosphorus, okay. ഇത് ചെയ്യുമ്പോൾ see I will have the alpha and this is the beta position. You will see exclusively the alpha position is being halogenated. Okay, so I have bromine here, okay. So I get ഇതിൻ്റെ പേരാണ് alpha bromo propionic acid, propionic acid, yeah. And again this can be undergo halogenation in presence of phosphorus to give me CH3C Br2 COOH. So this is again alpha dibromopropionic acid, okay. If I had taken the case of an aryl group, aromatic group, okay. So I have this is my phenyl acetic acid, sorry. Here if it undergoes chlorination in presence of phosphorus, I will get alpha position idana. So here you will see there will be ClCOH, okay. This is how the reaction goes by. Now let's look into the mechanism. So mechanism, there are a few steps, 4 steps to be exact, okay. So let me go through each step one by one. That is, the first step is where phosphorus reacts with the halogen to form the trihalide, okay. The first step. The second step is the reaction of the acid with this phosphorus trihalide. So if I have taken, I'm writing it completely, okay, and I have the trihalide, you have seen the reaction, നമ്മളത് പഠിച്ചതാണ് കുറച്ച് മുമ്പ്, that is RCH2COX ഉണ്ടാവും. 3 molecules, and H3PO3 is being formed here. That is എന്താ പറയുക, ആൽക്കനോയിൽ ഹാലൈഡ്, അതായത് ഒരു ആസിഡ് ഹാലൈഡാണ് നമുക്ക് ഉണ്ടാവുന്നത്. ഓക്കെ, സ്റ്റെപ്പ് 3ൽ എഗെയിൻ അതിൻ്റെ ഒരു ഹാലോജനേഷനാണ്, ദാറ്റ് ഇസ് CH2. ഈ ആസിഡ് ആസിഡ് ഹാലൈഡിന്മേ എഗെയിൻ there is a halogenation happening there. അപ്പോൾ ഇവിടെയാണ് my alpha positionൽ it is getting attached. Okay, and you will hear ഇവിടെ നമുക്കൊരു ആൽഫ, ഇത് ഇവിടെയാണ് ഒരു ആൽഫ ഹാലോ സബ്സ്റ്റിറ്റ്യൂട്ടഡ് കമ്പൗണ്ട് നമുക്ക് കിട്ടണത്. ഓക്കെ, നൗ ഈ ആൽഫ എന്താ പറയുക, ദിസ് ഹാലജൻ ആറ്റത്തിൻ്റെ പ്രത്യേകത എന്താ വെച്ചാൽ ഇറ്റ് ഈസ് എ വെരി ഹൈലി ഇലക്ട്രോനെഗറ്റീവ്. ഓക്കെ, so it will facilitate the release of this alpha hydrogen atom because of this. Okay, alpha hydrogen atomത്തിന്റെ release ആണ് അത് facilitate ചെയ്യണം. Now the last step involves, the fourth step is this RCHX, okay, will then react with another molecule of my acid to form the alpha halo acid, and again I will get RCH2COX. അതായത് നമ്മുടെ ഇവിടെ we get this term back, and then it goes again and again. Okay, so this is how the mechanism it is happening. Now what is happening now what is the importance of this reaction? Valare important reaction aanu idu, because it helps you in the synthesis of alpha halo acids. Okay, and ഈ നമ്മുടെ ഈ ഹാലോജനേറ്റഡ് ഇതിന്ന് നമുക്ക് ഫർദർ ഹാലോജനേറ്റഡ് ആസിഡ്സും നമുക്ക് ഇത് കിട്ടും. ആൻഡ് ഇവിടുന്ന് ദിസ് ആൽഫ ഹാലോ ആസിഡ്സ് ഫോം ദ ഫസ്റ്റ് സ്റ്റെപ്പ് ഫോർ ഫർദർ സിന്തസിസ്, ഓക്കെ, ഓഫ് വെറൈറ്റി ഓഫ് സബ്സ്റ്റിറ്റ്യൂട്ടഡ് ആസിഡ്സ് നമുക്ക് കിട്ടും. ഓക്കെ, that is by going through nucleophilic substitution and elimination. So you can see how it goes. Okay, so for example, I have a alpha halo, the alpha bromo propionic acid എനിക്ക് ഉണ്ടെന്ന് വിചാരിക്കും. Okay, now it can undergo substitution with ammonia, okay, and form substitution നടക്കുന്നത് നമ്മുടെ ബ്രോമിൻ ഇതിലല്ലേ. Bromine will be the one that will be substituted, and I am going to get see alpha amino acid കിട്ടി. Okay, so this is one set. Then it can you can treat it with alcoholic KOH, and what will happen is HBr will be released, and you will get an alpha beta unsaturated acid. Alpha beta position la unsaturation vannu. This is an alpha beta unsaturated acid. Another substitution you can do with OH, and I can introduce the hydroxyl group, that is Br will be replaced with an hydroxyl group, and you get alpha hydroxy propionic acid. So this is a very important, so that's why we say HVZ is a very important reaction, because കുറേ ഒന്നാമത് ആൽഫ ഹാലോ ആസിഡ്സ് ഉണ്ടാവും, അവിടുന്ന് നമുക്ക് പല സബ്സ്റ്റിറ്റ്യൂട്ടഡ് compounds നമുക്ക് ഉണ്ടാക്കാം. Okay, with that I'll end here. Thank you.